Okay, before we take a look at number 40, I just want to remind you that there are a number of videos that I've already posted on YouTube that go through each of the systems that I'm using in more detail. At this point, I'm going at a fairly brisk pace, so if this is a little too fast for you or I'm not explaining enough, please refer to one of the videos that's already posted on YouTube. And for factor by grouping and the box method, any of the videos from 11.4, almost all of them indicate both methods. And also I will refer to these rules for factoring. It's kind of our little roadmap to follow, so you might want to pause it and write that down if you don't have these handy. You want to be able to write these on a piece of paper at any given time so you're ready to proceed with factoring. It can be very confusing, and if you have a little bit of a roadmap, that can help quite a bit. Alright, so let's get started on number 40. They've asked us to factor by grouping. You could also use the box method. I'm just going to use factor by grouping. So grouping, you group together the first two terms. Alright, and then you group together the second two. And you look at the first two and see what's the GCF. So I can get an x squared out of there. And when I factor x squared out of those two terms, I am left with 3x squared. And this would be negative 5. Okay. Then I look at my next two terms, and the GCF is 3. So it'll be a positive 3. That's what I'm going to factor out. Okay, when I factor that out of each term, I'll be left with 3x squared and a negative 5. Okay, notice each set of parentheses is identical. That's what you're hoping, well, that's what you need to have happen when you're factoring by grouping. Okay, so this set of parentheses is the same as this set, so each set of parentheses is my common factor. So I'm going to factor out 3x squared minus 5 from each of these terms. When I factored out from the first term, when I factored out from here, I'm left with just an x squared. When I factor it out from here, I'm left with just plus 3. So this is the factored form of our original polynomial. And you can check it. If you multiply each term here by each term here, you will get these terms. They might be in a slightly different order, but each term will be there with the correct sign in front of it. Alright, so that's number 40. We'll take a look at number 42 now. And notice you're going to have to do a little bit of rearranging here. Okay, you're supposed to have the terms arranged with exponents in descending order. So I'll do that as the first step. 40x squared will come first. Then you'll have negative 82x. And then you'll have positive 18. And I think if you look at these numbers, you can tell there's a GCF here that we can factor out. That's number 1 on our list, GCF. So, looks like 2. Yeah, looks like a 2 is going to be the GCF. So we'll factor a 2 out of each term. And that will leave us with (20x squared) minus 41x plus 9. And then you proceed down the list. Do you have 2 terms? No. Do you have 3 terms? Yes. And something in front of x squared. So you simply multiply the first term times the last term. And I'm really just paying attention to the coefficients of 20 and 9. So that's 180. These signs, let me see, I'm going to be looking for a sum of negative 41. So that means whatever factors I pick, say 1 and 180, both of these will have to be negative. Okay, but I want a sum of negative 41. And if you proceed methodically, you'll list every factor, and somewhere in there should be a sum of negative 41. If not, this is prime and you can't do anything else. So let's see. I'm going to try to speed things up. Well, I'll go ahead and zoom out a little and just crank them out. All right. So 2 and 90. 3 and 60, 4 and 45, 5 and 6, 36, 6 and 30. Do I see a 4? Hey, you know what? I see my 41 here. I'm going to stop. So if I had a negative 5 and a negative 31, I could add those and I would get a negative 41, and that's what I'm looking for, is a sum of negative 41. All right, I'll zoom back in a tiny bit here. I think we'll go with that. All right. And the first term goes in the first box. Alright, I'll zoom back out a little. Not quite fitting here. First term goes in the first box. That's 20x squared. Last term goes in the last box. And all of this work was to find the terms that go in these other 2 boxes. Again, it doesn't matter. I could put a negative 5 here, or I could put a negative 5 here. It doesn't matter. You'll still get the right answer. So I'll put negative 5, negative 36, excuse me. And you always have to remember to put in your variables. And in this case, this was x squared, so this is an x, and this is an x. Okay? And now you just look for the GCF going straight up. I can get negative, the negative's almost out, so it comes out negative 3. Hey, 9 goes into 36, so I can get negative 9 out. There we go. That looks better. Negative 9. Going straight up here, 5x. Going straight across, looks like a 4x is the best we can do. And coming over here, negative is coming out. Notice with negative 5x and a 9, there really is no common factor other than 1. So I factor out a negative 1. Okay? And this gives us our answer. 5x minus 9 is one set of parentheses. Four x minus 1 is the other set. You have to remember to bring down the 2. Okay? Now let's just check this real quick. That would give us a positive 20x squared. That would give us a positive 9. And negative 5x, negative 36x would combine to give us a negative 41x. Okay? So this is the factored form of the original polynomial. So let's see, we'll also take a look at, that was number 42. We'll look at 44. I think we'll zoom in a little bit on this one. There we go. Okay, proceeding down your list. Number 1, is there a GCF? No. Number 2, do you have 2 terms? No. Do you have 3 terms? Yes. Is there something in front of x squared? Yes. So you can use box method or factor by grouping. My preference is the box method. So 4 times 9 is 36. If that's positive, that means I use positive times positive or negative times negative to get my 9. So that means I want a sum of negative 7. So I list all my factors, 1, 36, 2, and 18, 3 and 12, 4 and 9, 5 won't work, 6 and 6. Okay, for this to be positive, it's either both signs are positive or both signs are negative. For that to be negative, they must both be negative. Okay, again, I'm looking for a sum of negative 7. That won't work. That won't work. That won't work. That won't work. And that won't work. So this polynomial, oops, that's supposed to be I. It is prime. Cannot be factored. Let's see, 44. We'll take a look at 46. And let's see here. Determine, let's see, 46. Determine whether the trinomial is a perfect square trinomial. Okay? If you can pick up on this, it can be quite handy, especially when some of your values are real large. Okay? There's just a pattern within here that it's helpful to notice. Okay? So we'll look, I'll zoom in, well, I'll stay where we are. To start out, if you can't just see that it's what's going on, let's just say we'll proceed as if we were just trying to factor this, okay? There's nothing in front of m squared, so you grab your 36, list all the factors, 2 and 18, 3 and 12, 4 and 9, 6 and 6. Notice I'm looking for a sum of negative 12, so each term must be negative, and in fact negative 6 and negative 6 will add up to give me a negative 12. So look at the factored form here. You have m minus 6 and m minus 6. Okay? This can be written in an easier way. M minus 6 squared. Okay? Because you have 2 sets of parentheses. But what they're hoping you'll notice in terms of asking if it's a perfect square trinomial is you look at the 36 and you should by now be noticing, hey, that's a perfect square. What's the square root of 36? It's 6. And remember, you get to your middle term by adding or subtracting. In this case, if that's positive, the signs have to be the same. You would be adding. Okay? So what's 6 plus 6? Well, that would give you a 12. Okay? So you can actually just look at this problem and say, well, the square root of 36 is 6. If I add 6 to itself, I get 12. Is this a perfect square trinomial? Yes, it's a perfect square trinomial. If you can't do it that way, if you go ahead and factor it, if you get to here, I hope that triggers in your mind, oh yeah, well, it's a perfect square. It's a perfect square trinomial. Okay? Let's see, that's 46. We'll also take a look at 47, just to reinforce the point. What's the square root of 49? 7. What's 7 plus 7? 14. Is that what I have right there? No. Is this a perfect square trinomial? No. If this had been minus 14b, it would be a perfect square trinomial, but it's not. And I don't know whether or not it can be factored. I don't really care, because all they want to know is if it's a perfect square trinomial. Okay? This is just a yes-no question. Then we'll take a look at number 48. This one's a little more involved, but along the same lines, and it might help you see why this is kind of handy to know. Let's get another piece of paper here. Number 48. There is no GCF, so if we were to use the methods I've shown so far, you would have to multiply 100 times 49. That would give you 4,900, and I'm sure you wouldn't be excited about listing all the factors. So I hope you notice that 100 is a perfect square, 49 is a perfect square. Okay? What's the square root of 100x squared? Why, it's 10x. Well, okay, and what's the square root of 49y squared? It would be 7y. Okay, so if I multiply 10x times 7y, I'll get 70xy. And if I add it to itself, I'll get 140xy. So this is a perfect square trinomial. So the answer would be yes. And by the way, the factored form is sitting right in front of you. You would just have 10x minus 7y squared. This is the factored form of this trinomial. But again, they weren't asking what is the factored form. They just wanted to know if it is or is not a perfect square trinomial. So the answer is yes. And let's see. I think we'll stop there.